Okay, let's talk about logarithms. So, the $1,000,000 question. What is a logarithm? An exponent. Okay, so now, since logarithms are exponents, let's talk about properties of exponents for a very brief second. If I have something like this, 3 to the power of 7 times 3 to the power of 2, what does that equal to? 3 to the power of what?
9.
9. So even though you're multiplying the powers, what do you do to the exponents? You add them, right? And if I had 3 to the power of 7 divided by 3 to the power of 2, what is that? 3 to the power of 5, because when we divide powers, we do what to the exponents? Subtract. So you already know this connection of multiplying powers, adding exponents, dividing powers, subtracting exponents.
Do you not like divide those 3 and 3?
No. You just leave it because it's kind of like a magical thing, because if you have 3 to the 7 and if you write it out, 3, like 7 of them, yeah, and then 3 of them, you see how they'll cancel out, so you'll have 3 to the 5. Okay? So this is the idea we're going to stick with, that when you're multiplying powers, you add the exponents. When you're dividing powers, you subtract the exponents. So now, let's talk about some properties of logarithms. The first one is the product property. The product property says if you have log base m times n, if you're multiplying stuff inside the log, you separate the m and the n, you give each one its own log, and then you add them. Again, it comes from the idea that if these are all exponents, if you multiply powers, you add the exponents. So log of m times n is log of m plus log of n. Okay? When you're dividing, same idea, log m over n, you separate them, give each its own log, and then always think about if you're dividing powers, you got to subtract the exponent. So it's log of m minus log of n. Okay, so that's the product property and the quotient property. Do you have to memorize them? Yes, you do. The power property is the last one that says if you have log bm to the power of p, the p comes down and it becomes a coefficient. Okay? So, all right, so let's take some examples here. So first of all, it says express each of these in terms of log 2 and log 3. So what you have to do is you have to take the 96 and you have to write them as factors of like 2 and 3. Okay, so let's see how we can do that. So take the 96. If you divide by 2, what do you get? 48, right? And then if you divide by 2, 24. So if you're supposed to write them in terms of log of 2 and 3, you can only divide this by 2 or 3, okay? So divide by 3 this time, what do we get? 3 times 8, and then 2 times 4, and this is 2 and 2, right? I know, I should have started higher up. So what is this then? This is log of, so let's see what 96 is made of. How many, okay, there's this one lonely 3. How many 2's are there? 1, 2, 3, 4, 5, 2 to the 5. Okay, so I just rewrote the 96 in terms of these. So when you do the factor tree, you look at all of the numbers that don't have anything coming out from them. Those are the ones that you want to take. So you count how many of the 2's and the 3's and so on. So now I want to express them in terms of log 2 and log 3. Now I want to expand it. I want to apply the log property on this. So since I'm multiplying things inside the log, how many elements do I have in here? 1, 2, right? I have a 3 and a 2 to the 5. So I know that I'm going to end up with 2 logarithms. So I give each of those its own log. Okay? And because they were being multiplied, I add them. Next, this exponent will come down, so I get log of 3 plus 5 log of 2. Okay? All right, let's do the next one. That's the final answer. Okay, I have 32 and 9. I'm going to do those separately. So I'm going to do log of 32. So 32 is 2 times 16. So I can either divide by 2 or 3, right? So 16 I can divide by 2, another 2, and another 2. We didn't get any 3s this time, but it's okay. So what is that? 2 to the 5. And then how about the 9? That's 3 squared, right? So now, are these things being divided or multiplied? Divided, so I have to subtract. So log 2 to the 5 minus log 3 to the 2. Now what? Exponents come down. And that's it, we're done. Okay? Okay. So with these, we've done a lot of these, but we're going to do some more. Okay, so you have log base 2, root 32. What do I do with the roots always? Well, I can rewrite it as, Right. So I square it if it's in an equation, if it's like equal to something else, right? This one is just an expression, so I'm going to rewrite it like this. Log base 2, 32 to the half. Okay, now, what happens to the half? Goes to the front, so this will be 1/2 log base 2, 32. Okay, now, this is 1/2 times. Do we know what this is from the previous lessons? It's 2 to the 5th, 2 to the 5th, right? So what's the answer here then? 5. So let's remind ourselves, what am I doing? I want to find the exponent of 2 that will give me a 32. And it's a good thing to like start, just sort of like, not memorize, but like the more you do it, the more you'll learn. It's a good thing to know that 2 to the 5 is 32, right? So that's what we did there. All right, so this is just 5 over 2. Okay, so let's take a look at this next one. How can I rewrite this? Good. 49 to the 1/6. And now, the 1/6 comes down. So it's 1/6 times 3 log 7 to the 49. Now, this is a lot of stuff. But you know what? We divide and conquer, like do bit by bit. So first of all, do what you know. I know 1/6 times 3 is what? 1/2 times. And how much is this? Right, so the exponent is 2. So that means that's 1. Okay? So who would have thought, right? Who would have thought all this is just equal to 1? Okay? But look, neither would I. If I looked at this, I'm not gonna lie. If I just saw this, like my first instinct wouldn't be, oh, that's 1. No, I have to like think it through, right? But look at what I did. I did it step by step. First, what do? Oh, okay, rewrite this. Okay, then what? Oh, the power comes down. And then look, I did it half by half, right? You can't do it all at the same time. We don't do it all at the same time. You have to do it bit by bit. Okay, so let's move on. Take a look at this next one. What happens to the 4 here? Moves to the front. So we've been doing problems like this, but when you use the product property, somehow it makes a little bit more sense. So 4 times 3 ln of e minus, this also moves down, so 2 times 2 ln of e. Now, 4 times 3, 12. And what's ln of e these days? Just 1, right? Yeah, because they go away. It's 1. Minus 2 times 2, 4. ln of e, 1. So that's 8. Okay? All right. So far, so good? Okay. Expand logarithms. So how do we expand a logarithm? When you expand it literally, it's like, you know, you're going to have more logarithms than just one. So look inside the log. How many elements are there? I have a 4, an m squared, n to the 5. 3 elements means I need to end up with 3 logarithms. So log base 2 of 4. Now, is the m multiplied or divided in this problem? Multiplied. So plus log base 2 m squared plus log base 2 n to the 5. Okay. What will the first one get me? A 2. Plus, what happens here? 2 comes down, and the 5 comes down. So 2 log base 2 of m, 5 log base 2 of n, and then we're done. No. Those 2's can't cancel out. Because one is like if it was log 2, 2, then it would. Let me tell you what the common mistakes are. The most common mistake is students don't take the time to count how many elements there are, and then they end up with unsimplified terms. So, how many different things are in this log? What do you guys think?
2.
A lot. How many? More than 2?
3, 4. Stop guessing.
5.
1, 2, 3, 4, 5. That counts as another one. And this is where most of the mistakes will come in, is the student will just lump the 5 root z together, but they're separate things.
I would.
Yeah. Okay, so now, the thing is, so we're going to end up with 5 logs. The difference is we have some things as a numerator, we have some things as a denominator. Everything that's a numerator gets a plus, everything that's a denominator gets its own minus. So let's do it. Log of 2 plus log of x plus log y squared.
And would you like put a parentheses around that and then do minus?
No, I don't. I just do it in one shot. So here's what I do. I go, now I'm moving to the bottom. 5 is in the bottom, minus log 5. Root z is in the bottom, minus log root z. Okay? Yes?
I don't understand, like, counting elements. Like, why were there 3 on the last one? Like, wow. How do you...
So inside the log, what do you have? 4, m squared, n to the 5th. 3 things.
But the base doesn't count.
No, the base doesn't
Everything
count.
after the base.
Uh-huh. Here, we're not done yet, because this 2 needs to move down. And how about the z? How do we rewrite that? Z to the 1/2, and then what happens to that? It goes down. So it'll be log of 2 plus log of x plus 2 log y minus log 5 minus 1/2 log z. Huh? Anything that's in the denominator needs a negative sign. So
Is z an exponent or is it just
it's a variable, log of z. So if this was, let's say, like a 4-point problem, and if you just stopped after the first step, you would only get half the points. Because you didn't do that second step. You didn't do the power rule, right? Because this needs to come down, and that needs to be a root into an exponent, and then come down as a coefficient. Yeah.
Why is it half?
Because it's root z, which is z to the half.
Yeah.
So log root z is log z to the half, and then that half comes down. Yeah. Okay. So, next one. Okay. Here, this is a trick one. So I have ln of 2x minus 3. Because this is something plus or minus something else, this is considered as one single element. All right? The 2x minus 3, it's one element, one entity. Yeah, one entity. So take a look at what's going to happen here. Ln 2x minus 3. Okay. Minus, now we're moving to the bottom. Ln of 3. Minus ln of 4th root xyz. Just the 2x minus 3. But yeah, so we're not done yet. We're going to continue. So this one, so here's what we're going to do. This is ln of 2x minus 3 minus ln of 3 minus ln of, you got to put all the roots in exponent form. So xyz to the 1/4. Okay? Now what happens to the 1/4? It comes down, right? So ln of 2x minus 3, ln of 3 minus 1/4 ln xyz. Are we done?
No.
No. What now?
You've got to distribute that ln.
Right. You got to expand the ln. Okay? We got to expand the ln. ln of 2x minus 3. No. So that's the thing, is we don't use the word distributing because technically you can't distribute. We expand, but only if it's multiplied or divided. So minus 1/4, and here it's going to be ln of x plus ln of y plus ln of z.
You not do anything to the 2x minus 3?
No.
You don't touch?
No.
How do you know it's not?
Okay, so here's how you know. Okay, so
Because it's in the square root.
no. Here's how you know. So look, you have two different things here. One is ln of 2x minus 3. One is ln of xyz. Inside the ln, the terms have to be either multiplied or divided. So here they're being multiplied, you can expand them. If they're being added or subtracted, you cannot distribute an ln. So this, you can't do anything else with it. This one's done. Okay, because it's a minus or a plus inside. This one, because it's being multiplied, you expand. Okay, so when you condense a logarithm, you have to end with 1 log or ln. Okay, just 1 log or ln. So everything we did here, we're going to do in reverse right now. So if there is a plus or minus, if there is a plus, you're going to multiply. If there is a minus, you're going to divide. And any coefficients are going to become exponents. So same thing, but like in reverse order. So first, all of these come up and become exponents. So it'll be log 4 x to the half minus log base 4 x minus 2 cubed. Yeah.
That's only when you're condensing. You need to end with 1 and you need to
Yeah.
to the
Uh-huh.
exponent.
Uh-huh.
For like when it says
Right. Okay, now I still have two logarithms. So here's what I do. I put in one logarithm, and whatever this first one is, I just write that one. Okay, let me write it a little bit bigger. Okay, now the next one, it's a minus, right? If it's a minus, it's got to go underneath, and you say x minus 2 cubed. Okay, now you can leave it like this, or you can say log base 4 root x over x minus 2 cubed. Either one of these are okay. Okay? Questions? Okay, here we go. The 5 becomes an exponent. Yeah.
Which one do you prefer, the first one or the second?
I have no preference. They're both correct.
For the second one, wouldn't we make it a cube root also?
No, because it's just to the power of regular 3, not 1 over 3. Okay, so here, this is ln of x plus 1 to the 5 plus ln of x to the 6. This is ln of, okay, x plus 1 to the 5 times x to the 6.
So to get rid of that, why does that ln go?
Yeah. Hang on.
Can I move the x to the 6 to the
Yeah. Yeah.
Would it matter if you chose to do ln x to the 6 times x plus 1?
No, it's the same.
Okay, so you can do either one.
Uh-huh. This is the answer, yes.
Why does that ln go away?
Because you
One in
can,
front of-
because when you condense, you only need one ln.
It's like the same way you multiply.
Oh,
Okay. Okay, so change of base formula. Change of base formula says this. So when you have a logarithm of a certain base, you can expand it into two logarithms, giving them the same base. Right?